So again, welcome back, ladies and gentlemen. Today's second part of our lesson really is on multiplying rational expressions. And we're looking at example 2. There's actually 3 questions there, but for our class and the lesson, we're going to only do 2 of them, question A and C, if that's okay. And let me try to do question B on your own as we do it. These are, in a sense, pretty easy. It's a good segue to what I talked about in our previous lesson on simplifying rational expressions. Let's take a look at question A. It's 3a cubed over 2b squared times 10b cubed over 9a. Right? Now there's a bunch of monomials and a multiplication of 2 rational expressions. So the rules are still the same. You factor first, state restrictions, and simplify. Did they copy it wrong?
Yeah, it's 9a squared.
So what?
It's 9a squared.
I'm doing example 2a. Is that alright?
Yeah,
9a squared.
Oh, 9a squared. Thank you. 9a squared. Sorry. Thank you. So the first rule is we state the factor first. Done. There's nothing to factor. Everyone agree? So this one is actually pretty easy. The lesson for this is actually to focus on the multiplication aspect. But we still have to state restrictions, right? And so we look at this denominator, we look at this denominator. So there's our variables. Everyone agree that's b squared and that's a squared? So I think everyone's okay. A cannot equal to 0 for this one. And b cannot equal to 0. Done. Pretty easy. Any questions still from the class? So those are our restrictions. So now we start simplifying, which in this case, this one's pretty easy. Right? Using red chalk. The way that I like dividing out, and it might look messy, so hopefully it will follow along. I like doing coefficients first. I like doing coefficients first. Then I like doing variables second. So in this case, the 2 becomes a 1, and that 10 becomes a 5. This 3 becomes a 1, and this 9 becomes a 3. It's not always going to be in this crisscross pattern, but this is a traditional easy example. And so for the coefficients, we're done. And now we look at the variables. We have a cubed divided by a squared. And again, division means you're using that exponent rule to subtract those values. So 3 minus 2, or really you want us to do this way. A squared becomes 1, and this becomes 1. Because 3 minus 2 is 1, leave the 1 at the top there. And then b cubed and that b squared, again, how many b squareds can go into this? Well, all of them go there. So that becomes a 1. So it looks like there's a bunch of 1s here, but there are raised to the power. So to make it look a little better, let's look at the coefficients. We have 5 over 3. 1 times 5 is 5. 1 times 3 is 3. We have an A, and we have B. Notice these are crossed out because they became 1s. And that is our simplified answer. For some reason, this example, I think, caused some students problems. So just looking at it carefully and just trying to solve. Any question about that? If we were to change the question, I'm going to put it underneath. I'm just going to recopy it. So it looks the same for the first one, so watch what I'm going to do. 10b squared, or 10b over 9, I'll change that one. So it only changes b to the 1 rather than b to the 3. So the same thing actually happens. All the same restrictions, I think everyone's okay. A cannot equal to 0, b cannot equal to 0. 2 goes into 10 5 times, so it's exactly the same for the coefficients. But I'm just trying to get you guys to see this one, is that this b changes that to 1, and the same thing happens there. So now we have this answer in this orange example, 5 and 3, and that's our A, and that's our B. So I was trying to show you just like there's a slight modification to the question. I don't know, hopefully maybe the camera's catching that. If not, it's just something to think about, that sometimes you can have still variables in the denominator, right? It doesn't keep on canceling out or dividing out. Any question on example 2A from the class? Any questions at all? In order to see that, if you need me to make it bigger, it's hopefully the projector's not blocking your page. I can always move it. Everyone okay with that? I don't like example B because it's very similar to this, and I don't, I mean, this might still pop up on our quiz, but it's example C that is a bit more interesting. So notice multiplication, notice if you recall from our very first lesson of multiplying challenging polynomials, notice we don't do that, right? So we try to factor everything out. I think everybody agrees we have to factor this one. That's why the rule's there. So I'll do the first one. Right? I think that's x plus 3, x minus 2. X squared plus 2x minus 15, I think that is x plus 5, x minus 3. Everyone okay with that? Everyone, if I made a mistake? I'm going to close that door. These students are being too loud in the hallway. They're being rude students. That's what I said. We try to record these up live here. Oh. Any question here? Any volunteer? Someone new perhaps? Maybe try to impress me? I know it's one of the real second name. Anyone new? Maybe, I don't know, Ivan or Sam or Melanie? Sorry?
The restriction?
Yeah, if you don't mind.
Oh, negative 5, 3.
Negative 5 and 3. There's one more. So let's go slow. Let's get negative 5. That's for this one. Everyone agree? 3. But there's one more restriction.
0.
It's not 0. You're just not looking at the right spot. That's okay though. It's okay.
It goes on the top.
It's not on the top either. Don't worry. Don't worry. I don't want to stress you out. Don't worry. Annika. 2. 2. It's right over here.
Oh, yeah.
So there's another rational expression, right? So there is 2. Before we continue, negative 5, 3, and 2. Everyone okay with that? Any questions still? Notice again, restrictions are looking only at the denominators. So it's okay, don't worry, it's good. I appreciate the participation, right? So then we start crossing things out. And that's why, in some sense, multiplication is so much easier. So much easier. That's why a lot of you say, this is easy. Yeah, we'll get her in a moment. Anything we can divide out? Oh, Genevieve, you have a question?
Why wouldn't negative 3 be 1 then?
Sorry, what?
Why wouldn't negative 3 be 1 if?
Good, negative 3 is in the numerator.
Okay.
And so we can get one more time. If x was ever negative 3, and I'm just going to put this in. So negative 3, I'll leave the plus 3, negative 3 minus 3. Oops. Do that. This is a good question. Before we finish. So many. We had to change the colors.
Oh, wait.
Sorry, this is hard for me to do. Okay. So don't get me wrong. This becomes 0. This becomes negative 5. This becomes negative 6. This becomes 2. This becomes negative 6. This becomes negative 5, right? So this 0 times this is 0. 2 times this, which is positive 60, is 0. This is an answer. Hey! It's like me meeting, 60 hot guys or girls and say, no, thanks, I don't want to see you. Right? That's me, strike me out. 0 is an answer. Oh, 7. Oh, right? Boo-hoo. But it's an answer, though. 0 is an answer. Right? It's when we divide by 0, that's the problem. That's why it's always the denominator. That's why we stress at the beginning of our warm-up for today was the stating restrictions, right? So it's combining things. It's a good question. Anyone else? That's how you can kind of check. So like, you don't go overboard, right? You don't say negative 3. And that could be, again, a question on the quiz. Is negative 3 a restriction? You'll say, yeah, sure it is. Oh. Anyways, can we continue on? Anyone want to try to tell me the divide out? Anyone? Vanessa? Sure.
The x minus 3 and x minus 2.
X minus 3 over here and here. We're okay there. And x minus 2 that Vanessa said that. Huh? So our final answer, I think everyone agrees, is this. Before we continue, everyone okay? That is why, one more time, if you started to multiply all this out, that's why, ladies and gentlemen, when we talk dealing with fractions, you're actually supposed to divide up first. That's the whole point. That's why a lot of you, if you do a question like this, We don't like 14 over 6. We actually like doing this first. Oh, it's actually 7/3. This is the idea of dividing out that we were taught in grade 9. That some students, and they said it was Jen, when I was taught in elementary school or middle school, they just told us to multiply 2 times 7 and 3 times 8, which is correct. This is correct. It's just now you're seeing where that skill set is popping up now. This is how you do it. No one wants to multiply this all out. Can you imagine? You're going to get a huge trinomial that's almost impossible to start dividing out because you can't. Even I would find it difficult. That's why factoring is so important. Let's just stop this.